Welcome back, students. So I'm going to take up the last problem for today, problem number 4.3, that belongs to development of surfaces. This problem is special in one way. I'll tell you what it is. You can come over to the sheet. This is the problem. Problem number is 4.3. The reference number is 14 from the VTU primer. The drawing number is 15. Let me read out the problem for you. It's a pentagonal prism of base side 20 mm and height 40 mm. It is resting with its base on HP. This is all quite okay. A base edge is parallel to VP. That is also fine. The prism is cut as shown in the following front view. Once again, you are given the front view of the prism. Draw the development of the lateral surface of the prism after considering the cutting planes. Now I was mentioning the speciality of the problem is this. You are given the cutting plane like this and this. In the first problem, there were two different cutting planes. In the second problem also it was just one cutting plane. And in the third problem, if you see, the cutting plane is moving like this and it is going like this. So it is just one, the cutting plane is changing its direction at certain place. That is the specialty of this problem. And the other specialty is these two edges are shown dotted in the front view. So based on this, you should be able to imagine what should be the front view like. How should the front view be drawn? The top view be drawn. This is the front view. In the front view, you are given these two longer edges invisible. Okay. So of course it is given that a base edge is parallel to VP. Now the question is whether you should draw the base edge, the pentagon like this, or you should draw the pentagon like this. That is the problem in front of you now. You should decide. You are just given that a base edge is parallel to VP. So can I take it nearer to XY line or should I take it away from XY line? You are going to view like this. When you view like this, see, this and this will not be visible. That's why they become dotted here. Okay. But for this position, you will be able to view this as well as this. Okay. So whatever front view is given corresponds to this position of the pentagon. You should realize this. Okay. So when you look from here, this is visible, this is visible, this is also visible. But these two are invisible as they are away from the observer. So you should draw a pentagon with this position. So this is very important to know because you are not given the top view. You are just given the front view, these two lines, these two edges have been made dotted. So this is the position of the pentagon I should start with. Okay, I'll erase this now. Let us start by drawing the orthographic projections first. Okay. This is my XY line, VP and HP. I'll draw the pentagon just now I have shown with the base edge parallel to XY line and nearer to it. This has to be 20 mm side. Now complete the pentagon. Let me slightly widen the angle. You can still reduce it. So let me start naming from this corner. This is also a prism. CC1, DD1 and then EE1. The base edge is given as 20 mm. So I'll mark it here. Let us find the center by drawing perpendicular bisectors. So this is the center, O1. Now let us draw the front view. The height is given as 40. So double this. You have to draw the front view using light lines first. Now these will be dotted as I was mentioning earlier. I'll explain it once again. And this will be a chain line because it is an axis. So this is the position of the observer. For the observer, AA1 is visible, BB1 is visible, CC1 is visible. So this is A dash, A1 dash visible. Where is comes next BB1. I'm sorry, this is also BB1. So this will be a solid line. You cannot show the axis. BB1 is visible. So B dash, B1 dash, then this is C dash, C1 dash. Whereas DD1 and EE1, as they are away from the observer, they are invisible. We made them dotted. D dash, D1 dash, I'm sorry, this is E. This is E dash, E1 dash, this is D dash, D1 dash. That completes the front view. I have made it light because I have to consider the cutting plane and make the required lines dark. Now before I draw the cutting planes, let me complete the development for the entire pentagonal prism. We'll start with AA1. Of course the height is given as 40 here. Then AA1 to BB1, how much is it? 20. So like that you have to mark 5 edges, 20, 40, 60, 80 and then 100. Now you draw lines parallel to each other since it is parallel line development method. 2, 3, 4 and 5. Now you can name the longer edges B, B1, C, C1, D, D1, E, E1 and end with A, A1. The total length of the development is going to be 5 into 20, 100. And each of the base edge is 20. So this gives the development for the entire pentagonal prism. Now let us consider the cutting planes. Exactly, it is half the height. You can see here, this is 20. The total height is 40. This height is given as 20. So how is the cutting plane coming from the corner to the midpoint? This is how the cutting plane is coming, and then it is changing its direction, moving like this. From the top, mark a distance of 15 mm. This distance has to be 15, and then this is how the cutting plane is proceeding. Okay, this is its path. Now you need to draw the development only for the bottom portion. That portion can be made dark now, including the dark line, dotted lines. This should be light. Should be a light line. So you need development only for this portion. Now let us start naming the points. I'll start from here. 1 dash, section points. 1 is on AA1, longer edge AA1. Now you can't name this now because this is a dotted line. We'll come back and then name it. Right now it is only the visible edges. Go to this point, this is 2 dash, 2 is on BB1. Now go ahead, this is also an invisible point, go here, 3 dash, 3 is at C, exactly at C. Now you can come back and name the points on the invisible edges. 4 dash, put it in brackets, 4 is on DD1. Yes, now comes the very important point in this problem, this point. Okay. Make it a point whenever the cutting plane changes its direction, that point has to be named by 2 section points. It's very important. Even in the last problem I was mentioning, when the cutting plane cuts either a base or a top face, that particular section point has to be named by 2 section points. Even here, when the cutting plane changes its direction, make it a point, you have to name it by 2 section points. Okay. So if 2 is on BB1, where is the other invisible points? That is 5 dash. So how to locate it? Now if you look at this location, 2 is on BB1, which is visible. There is another rectangular face which is behind, that is this one, D, D1, E1, E. It is shown as dotted. So the point 5 is exactly lying on the center line of the rectangular face D, D1, E1, E. D, D1, E1, E. So I'll mark like this, point 5 on the rectangular face D, D1, E1, E. Actually, in fact, that rectangular face is behind. This longer edge BB1 is in front, D, D1, E1, E is behind. So that's why I'm marking 5 as invisible point. Then comes this point, 6 dash, 6 is on E, E1. That is also invisible. So you have totally 6 points, 6 section points. If you look at the VTU primer, a mistake was committed. This point 5 was not marked. There is a mistake in the primer. Okay. Only 5 points, section points were shown in the primer. So please make a note of it. Okay. Point 5 is missing there. Okay. Now, so what is important to be noted here is whenever a cutting plane is changing its direction, the point where it is changing its direction has to be named by 2 section points. That's important. Okay, now the remaining part is very easy. You just have to locate the points on the development. Start with 1. 1 is on AA1. You can locate it here and also here. Then comes 6. 6 is on EE1. Locate it here. Then comes 2 and 5. Where is 2? 2 is on BB1. It is here. Then 5, I said it is on the rectangular face D, D1, E1, E. In fact, it is on the center line of its rectangular face D, D1, E1, E. And here you will find D, D1, E1, E. That's the rectangular face. And you draw its midpoint, take its midpoint and draw its center line. This will be a light line. So on this line, the point 5 will lie. Along this line, this should be 0.5. So very important point in this problem. 0.5 is an important point. Where is it? It is on the rectangular face D, D1, E1, E, and it is lying at its center line. Now comes the point 4. Point 4 is on DD1. This is 4. And then 3 is at C. 3 is here. Connect the points using straight lines. 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, and 6 to 1. Now the bottom portion, the boundary should be made dark, and the lines along the longer edges, BB1, CC1, DD1. This line need not be made dark because you are not going to fold the sheet there. That line is drawn only to locate 5 and this. That's it. This is the development. Even when you are using solid edge, this should be typed. Okay, development you should type and paste it here. So what the mistake that was done in the primary is 5 was not located. So the point 4 is straight away joined with this point. So that becomes a mistake. Okay. So if you want, you can draw this on a sheet, cut it, and then fold at these locations and see in the front view it looks like this. You can check yourself when you draw the development. Okay. So this problem is so special because of two reasons. One is these two lines are given dotted. You should be able to imagine what should be the position of the top view. That is one thing. The second thing is changing in the direction of the cutting plane. Okay, this point is an important point for this problem. Otherwise the other things are simple. Okay, so you can have a glance at this. This is going to be your third assignment under development of surfaces. So these 3 videos I am going to upload to the Google Classroom today. Of course, I think I'll give the last date as 22nd. I'll be giving the last date as 22nd of May. You can submit before that. So that's it from me, students, for today. I'll come back with the next set of videos, I think tomorrow itself, so that you will have enough time for practicing these problems. But the due date will be at least 1 week time for 3 assignments.